This is a walkthrough of problem 3 on practice exam 2 of module 7 in the book Problem Solving Guide for Mechanics and Thermodynamics. We have a hinged overhang, 8 feet long, mass of 12 kilograms, hinged at one end and supported with a cable at the other. The overhang makes an angle of 65 degrees with the building, and the cable makes an angle of 30 degrees with the overhang. What is the tension in the cable? We have a nice diagram there. Put the forces on the overhang. We have gravity acting in the middle. We have a tension along the cable at the end, and we have the hinge force in some direction. We know the direction of the gravitational force, it's down. We know the direction of the tension, but we don't know the direction of the hinge force. We just estimate it, put it up there, something like that. And we don't even need to get that, because all we need is the tension. And to get the tension, we just take torques about the hinge right there. Take torques about the hinge. This force is irrelevant. We have gravity rotating it clockwise, and we have the tension rotating it counterclockwise, and the torques from those two forces must balance. To get the clockwise torque from the gravitational force, we need the angle it makes with the overhang. Something like right here, and the angle it makes is 65 degrees. That's the same angle. There's some kind of theorem in geometry, alternate vertical interior angle theorem or something like that. I don't know. But that's 65 degrees. And we want the opposite side, the length of the opposite side, which means we're going to use sine. So the component of the force that's perpendicular to the overhang is F gravity sine 65 degrees, and it's right there. Here's our right triangle. There's the right angle right here. That's F gravity sine 65. We can get rid of that. The clockwise torque from the gravitational force is the force that's perpendicular, F gravity sine 65, times the distance, which is 4 feet. The overhang is 8 feet long, and gravity's in the middle. So there is the perpendicular force rotating it clockwise. Now that we can focus on the torque produced by the tension in the cable at the end, we want the perpendicular component. That's the component that's rotating it. So that's 30 degrees. We want the opposite side. We want this length, which is t sine 30. Let's put that in the diagram. There it is. We can get rid of the tension. Now we have the two forces that are rotating it. The counterclockwise torque from the tension, it's 8 feet away. The perpendicular force is t sine 30. The torque is t sine 30, 8 feet. This thing is not rotating, it's in static equilibrium. Those torques must balance. So torque clockwise equals torque counterclockwise. The clockwise torque is F gravity sine 65 times 4 feet. The clockwise, t sine 30 times 8 feet. We can substitute 120 newtons for the gravitational force. It has a mass of 12 kilograms. And we can solve for the tension, and we get 109 newtons, and that's the answer to the question. It's probably a good idea. There might be a question on a test sometime that says, what's the force on the hinge? What's the force the hinge exerts on the overhang? And you probably should do that. Start here. Don't look at that diagram. Look at the original diagram, but now we have numbers. 120 newtons straight down, 109 newtons up at 30 degrees from the overhang. What's that? Here's the answers if you want to check them. The horizontal component is 62.4 newtons right here. The vertical component is 30.9 newtons right there. And if you want the magnitude, it's 70 newtons, 26 degrees above the horizontal to the right. So that angle from the horizontal is 26 degrees. That's problem 3 on practice exam 2 of module 7.